I'm George Miller, Student Engagement Manager at the Henry Royce Institute, and I'm joined today for this standout skills talk by another speaker from Royce, Stephen Pryce, the data curator. So this series is the aim of this series, sorry, is to provide you material science researchers with some of the supplementary skills and techniques you might not encounter as part of a typical PhD program. And today's talk continues, hopefully, the strong start that we've made to this year's series. So I'd just like to run through a few points of housekeeping. Your video and mic should be off without the ability to switch them on from your end. This is just to keep any distractions at a minimum, and we can all focus on the speaker. There will be some time for Q&A at the end. If you do have any questions, please write them in the chat box, and I can then put them to Stephen, or he can read them himself. And you're welcome to submit some questions during the talk. If you do have to leave for any reason, this talk will be recorded and published on the Royce YouTube channel for viewing next week. And you can find all the talks from our series so far on there, including last month's talk on road mapping for strategic navigation and alignment by Rob Farl of the Institute for Manufacturing in Cambridge. So I'd just like to introduce today's speaker, Stephen Pryce. Stephen holds a bachelor's in experimental psychology and a master's in applied neuroscience psychology from the University of Bristol, with a heavy focus on statistical analysis of data. For the last 3 years, he has worked in the higher education data analytics with posts at the University of Oxford, the University of Winchester, and the University of West London. Now, as data curator at the Henry Royce Institute, Stephen is tasked with advocating for open data practices, simplifying the processes for researchers to comply with public funding policy, and enabling an effective transition to best data practices. In his talk today, Stephen will address the question, what is open data, while exploring benefits to scientific progress, the public, individual researchers, and showing the existing successes of open data through materials case studies. Finally, Stephen will explore the obstacles between current practices and achieving successful adoption of a cultural shift towards open data, and close the session with a demonstration of Zenodo, followed by a Q&A. Open data has already made a huge impact on other areas of scientific research, with genetics and other life sciences benefiting in particular from this shared approach. This push for open data from within Royce is just the start with this within materials. So, it's a great point for you to start. And without further ado, I'd like to hand over to Stephen. Thank you.
Thank you, George. So welcome again to today's webinar. My name is Stephen Pryce, and today I'll be presenting on the topic of open data in materials science. We'll begin with an introduction to the Henry Royce Institute before covering definitions of key concepts and key terms. We'll review the objectives and benefits of open data before showcasing these in 2 case studies in the field of materials. I'll address the question, why share your data? And after we've done that, we'll look at methods for how you can share your data openly before considering potential barriers to open data and solutions to these barriers or ways around them. We'll end the session with 2 live demos, one for Zenodo, which is a general repository, and one for Creative Commons license chooser, which enables you to create a suitable license for your data for sharing, before finally having 15 minutes for questions and answers. So if you have a question during the talk, please save it for the dedicated space at the end. The Henry Royce Institute is a UK National Institute for Advanced Materials Research and Innovation. Royce identifies challenges and stimulates innovation in advanced materials research to support sustainable growth and development. And this vision underpins the broad research endeavour of the national materials community. Royce is a national institute with a regional footprint, spanning across 11 partner and associate partner institutions, including the University of Cambridge, the University of Oxford, and the University of Manchester. Royce has received a major investment from the Engineering and Physical Sciences Research Council, funding the development of 6 new buildings and further development of 4 established centres. As promised, I'll move on to some definitions of the key concepts for today's talk. First of all, we have open publication of research. This refers to the practice of making research outputs, such as articles, theses, or book chapters, freely available to the public. And typically this involves publishing in open access journals or repositories where the content can be accessed without payment barriers or subscription fees. Generally, material scientists are very good at this. So I'll move on to the next definition, which is really the key focus of today's talk, and that's open publication of data. This refers to the practice of making research data freely available to the public and can include datasets, raw data, and other supporting materials that underpin research findings. Open data is typically shared through data repositories or platforms that ensure proper metadata standards, citation practices, and compliance with ethical and legal considerations. So the aim now is with open data is to move beyond provision of supplementary materials with a journal article and publish the data separate from the article. The next key concept I wish to define today is metadata. So metadata is quite simply data that provides information about other data, so data about data. It serves as a descriptive mechanism to help identify, locate, and manage data, and metadata can describe a wide range of attributes about a data object, such as its content, context, structure, and quality. Now, pictured here, we have hopefully a very familiar example of a piece of data. It's a classic album. Actually, the data on this album is the music itself. And if we consider that, then the metadata could include fields such as the artist, title, the release date, the number of tracks on the album, the playtime, the label, copyright details, the media type, and details of the studio where the music was recorded. The last item I want to define is a DOI, or a digital object identifier, which is a unique alphanumeric string used to identify digital objects like academic articles, research data, or presentations. It provides a permanent link to their location on the internet, and the benefit of a DOI is they ensure reliable citation and access even if the web address changes. So here we have two examples of DOIs. On the left, we can see a DOI listed in its natural habitat above the abstract of a journal article. So I would imagine as junior researchers or doctoral students or senior researchers, you're hopefully quite familiar with seeing DOIs here. And on the right, we have a structured example of a DOI. So we can see it begins with the URL of the DOI, followed by the prefix, which is split into the DOI registry and the registrant, and finally the suffix, which can also be referred to as the DOI's object. So we'll move on now to the objectives of open data. These are to enhance transparency, reproducibility, and verification of research, to foster collaboration between researchers across institutions, across disciplines, and between nations, and to accelerate scientific discovery by allowing others to reuse and build upon existing data. So what are the benefits of open data? First of all, there's a collective benefit. Enhanced transparency of research increases the reusability of that research. If the materials published enable other researchers to replicate your findings, the research is reusable. Whereas in the absence of openly published data, this may not be the case. And this matters because replication or falsification of research is of paramount importance to the scientific method. Furthermore, technical errors and QRPs, or questionable research practices, are more easily identified if metadata and data are published openly. Finally, researchers can build on each other's research, collaborate, and avoid repeats of previously established negative findings, addressing what has come to be known as the file drawer problem. There are also some considerations to be made concerning global accessibility. Open access to research data ensures that scientists from all over the world, including developing countries, can benefit from the latest scientific discoveries. By making scientific knowledge widely available, researchers can contribute to solutions for pressing global issues such as climate change, health crises, and sustainable resource management, which disproportionately affect developing countries. There are also benefits to individual researchers. As discussed, open publication of data results in increased visibility and citations, and open data practices foster a collaborative environment between researchers. Beyond this, many grant and funding opportunities in the field of materials science now include requirements around open science and open data, and your career could depend on it. Many materials roles are increasingly incorporating evidence of commitment to open data or open research and experience with openly sharing data in their person specifications for researcher vacancies. So I wanted to showcase the value and the success of open data in some projects set in the materials field. We'll begin with the materials project. Spearheaded by the US Department of Energy's Lawrence Berkeley National Laboratory, the Materials Project is a collaborative initiative providing access to a vast database of materials properties. By making the data and associated tools publicly available, the Materials Project fosters collaboration among scientists from different institutions and disciplines. Consequently, the transparency and reproducibility of research are improved, as other researchers can validate findings and build upon previous work using the same datasets and computational methods. Open data from the Materials Project supports the use of machine learning and artificial intelligence to predict material properties and discover new materials. Furthermore, companies and startups can leverage this data to develop innovative products and technologies, accelerating the commercialization of advanced materials. This accelerated discovery of new materials has direct implications for technological advancements in various sectors, including energy, electronics, and transportation. By providing access to valuable data, the Materials Project lowers the barrier to entry for startups and smaller research institutions, promoting innovation and economic growth. The second example I wish to showcase comes from the Open Quantum Materials Database, or the OQMD. This project is an extensive database of materials properties calculated using density functional theory, or DFT, and the project contains DFT calculated data for over 600,000 materials, including compounds, alloys, and theoretical structures. The database is publicly accessible, allowing researchers to download data and use it for various computational and experimental studies. The project offers tools for data analysis and visualization, facilitating the exploration of materials properties and relationships, and researchers use the database to rapidly screen and identify promising materials for various applications. The pre-computed data enables quick hypothesis testing and narrows down candidate materials before experimental validation. The large dataset allows for machine learning and data mining approaches to uncover patterns and relationships that may not be evident through traditional methods. A vast amount of data, methodologies, and results are shared with validation by peers, allowing researchers to identify new materials with desirable properties. So hopefully I've provided some fairly compelling reasons to engage with and share open data. But I have further reasons beyond that. Some of these come from compliance with funding policy or public funding policy. The UKRI, for instance, have stated that publicly funded research data are a public good and produced in the public interest. As such, they should be made openly available with as few restrictions as possible in a timely and responsible manner. And I did touch on this, but to elaborate, your career may also depend on it. Pictured on this slide is a person specification for a research role in the field of materials engineering based at the University of Manchester. The essential criteria lists sharing in public repositories, and the desirable criteria specifies a commitment to open science and reproducibility. Research posts within the field of materials are featuring more and more frequently evidence of a commitment to open data in their criteria.
You've got no gas.
I've got no gas.
Yeah. There's nothing coming through into the boiler. You know where your gas meter is?
Yeah.
This is becoming more and more commonplace, and if you are a doctoral student or junior researcher, You are brilliantly placed to be ahead of the curve, acting as an exemplary researcher for best standards of practice.
Might be on a prepayment.
So having addressed the benefits of open data, the next logical question is how you can share your data. First of all, there are institutional repositories. So you should check with your own institution on what these are and how you can use them. You can also consider using domain-specific repositories, and most commonly, you can use general repositories such as fixture, Dryad, or Zenodo. Zenodo I will be demonstrating the use of towards the end of this webinar. You can also upload your code or data to GitHub. And when uploading code or data, you should use comprehensive metadata and use open, non-proprietary data formats and standards. You may benefit also from creating a research data management plan with a section detailing how you will share your data. And you should use open licenses with proper attribution. So that brings me to the next point, which is licensing. So a Creative Commons license allows reuse and redistribution of research while the original author
It's
or authors retain ownership rights. And there are several different licensing options for a Creative Commons or CC license. First of all, we have the CC BY license or attribution license. Now, this allows others to distribute, adapt, and build upon the research, even commercially, if they credit the original creation. A CC license has several additional options or features, such as a share-alike, non-commercial, or no derivatives clause. The share-alike states that any derivatives of your work have to share it under the same conditions as the original work itself. Non-commercial simply states that the work cannot be used for commercial gains, and no derivatives essentially states that the work can only be used for educational purposes. So the next question is, how can you apply a CC license to your data? Well, most repositories such as Zenodo, which we'll see, have an option to apply a CC license to your dataset when you upload it. And when doing this, you can also stipulate an embargo period to protect any intellectual property. Alternatively, you can use the Creative Commons license chooser. There's a link provided within this presentation, and I believe at some point George will put in the chat a link to this website. I'll be demonstrating that as well. Now, you can also check your institution's resources. So find out what your institution's chosen repository is, as mentioned. Contact your library to establish what resources they have for open data, and find out if your institution has something alike to an Office for Open Research. Finally, keep up to date with institutional publications, policy updates. I've dedicated the latter part of this webinar to identifying and exploring solutions for barriers to open data. The first concern may be simply lack of incentives. So open data practice, as a solution to this, open data practices are increasingly incorporated in performance metrics at institutions and as requirements for funding grants and other sources of funding. So we've hopefully seen as I said before, some compelling reasons for the case for open data. The second concern may be around intellectual property or IP. So we've seen how the use of Creative Commons licenses and embargo periods protect the ownership of research while allowing reusability. Researchers can stipulate the relevant terms to comply with funders or institutional requirements, and we'll see that the putting an embargo period on an open data set in practice. Another concern may be around fear of being scooped. So most general purpose repositories allow researchers to stipulate an embargo period when uploading their data, and this allows the authors to benefit from their research before openly sharing the data. Another reason not to engage with open data may be not knowing how to share the data. So hopefully by the end of this presentation, after we've concluded with the demonstrations, you will be equipped with the knowledge to share your data. So without further ado, I will begin the demonstration. So we'll start with Zenodo. Now, this is the Zenodo home screen. We can see here we've got a link to the home screen. We've got a search box, a tab for communities or your dashboard, login details, and recent uploads. These are all uploads from today. If we look at the dashboard, this is my dashboard. We can see I've uploaded open data and material science. So the slides for this presentation are available on Zenodo. So this is the live instance of Zenodo. For today's demonstration, I'm going to be using the Zenodo sandbox. And we can see this looks very similar. There is just a mention here. This is the Zenodo sandbox instance used for testing purposes, and you can find the production instance of Zenodo at zenodo.org. Okay, so that's basically Zenodo. Now, if we want to upload a data set, we need to be logged in. You can see here I'm logged in as Stephen Pryce. And if we need to upload a data set, we can first of all go to the dashboard and click upload, or we can click the plus icon with the drop down and click new upload here.
All we did was turn the water off to the boiler in the basement when we did it. It's not nowhere near the rooms.
Okay. So the next option we have is to select the community where you want to submit your record. So we'll see here community options. There's 820 pages of communities. You just peruse those at your own leisure when you're using this. I'm not going to select a community, so we'll just close this. The next obvious thing to do is to upload the file. So you can click and upload, or you can drag and drop. I'm just going to drag and drop. And for the purpose of this demo, I'll just be using a text file.
What's happened? What have you called?
Which is just quite simply says this is a test upload.
Whereabouts is that in the building?
So there we have, we've uploaded the text file. We then need to provide some basic information. So the first question is, do you already have a DOI for this upload? If we have, we can enter it there. If not, we can select no, and we can assign a DOI to this digital object. Now, because I'm in the sandbox instance, this DOI is not real and it will not resolve to anything. But in the live instance of sandbox, the live instance of Zenodo, you can assign a DOI like that. We'll now need to select the resource type. So we have a number of options here.
Joe thinking so we were in the
I'll select dataset. George, I'm not sure if you can hear me, but I believe your microphone is still on. So then we have the option of adding a title. So I'm just going to call this Zenodo test upload. Now you can see this is an autofill response. Is that going to cause issues because I've already uploaded or saved a draft with the same name? No, because we're going to be using versioning. Then we would need to add a publication date. So this can be a date in the past, in the future, or it can be today's date, which is what I'm going to use. We'll then need to add details of a creator. So you should, in theory, be able to search by an ORCID or another reference or identify it in this box here. My ORCID does not appear in that search box due to apparently the twice yearly data dump has not moved it over. So we can add my details manually. And we can copy the ORCID ID there. We can also add affiliations. I'm going to add the Henry Royce Institute. And we can select a role. So whilst my job title is data curator, I'm actually going to select editor because in respect of this file, that's what I am. I'm the editor. I'm not the curator of the data. We can have the option to save and add other. I'm just going to click save. We can add a quick description. And then we have something familiar, hopefully from the talk, a licensing option. By default, we're given the option of a Creative Commons Attribution 4.0 international license. For instance, if we wanted to add the share alike clause, we could do that. And from here, we have lots of optional fields, including contributor, keywords, which you can add like this, materials, engineering. And if we're working with nanomaterials, we can add that as well. So choose the relevant options for that field, or keywords rather. Now you can select your language, so you can select anything. You can select Italian, and there's different options, different types of Italian. You can select French, or I'm going to select English, and there's a whole list of different types of English. So just make sure you choose the appropriate language. And then we have versioning. So you can see here, I've been inconsistent in my versioning format. So I'm going to go with the more recent format. The last upload was a 1.6, so I'll call this a 1.7. And that deals with the issue of having multiple uploads or versions of the same data. The publisher you should leave as the default Zenodo. You can add details of any funding awards or grants, and you can add details of an alternate identifier. You can also add details of related works or references by adding a reference string. And you can add details of any software you have created for the project, such as, or rather by adding the URL for the code for that software, by adding the programming language, and by adding the development status of the software. You can add publishing information or details of publishing information for any journal, journal, imprint, or thesis which you published your work in. And you can add details of any conferences which you discussed the dataset or the accompanying research at. Lastly, we have domain-specific fields. So there's a whole list of these. We can see here, for instance, class, which is the taxonomic class of the organism. That's not going to be relevant in materials fields, but we see here we've got a material sample ID, and we can add field and close, and I can just assign that a value of 1, 2, 3, 4. And there we have it. That's all the information we have the option of, or we are required to submit for the data upload. We can now save the draft, preview, publish, share, or stipulate that the visibility should be public or restricted. If we select restricted, we have the option to add an embargo period. So we can embargo this until 2024 October. Sorry, that's in the wrong format. We need to use a hyphen and not / October the 1st. And I've done it again. October the 1st. And we can say the embargo reason is for demo purpose. Okay, so as I say, we can save that. It'll appear in our dashboard. We can go back to edit that and publish it. We can preview it, or we can go ahead and publish it. So let's publish this. Are you sure you want to publish this record? Yes, publish. And this is what it'll appear like to anyone that views your data. We've got the name of the file we uploaded, test upload sandbox.txt, and the text states this is a test upload. The description, this is a test file for demo purposes. The title is Zenodo test upload. We've got the number of views, number of downloads, the version, which is 1.7. Got details of any communities we've uploaded in, the keywords we specified. We've got the embargo details, options to download, and we also have the DOI assigned to this digital object. We have the resource type, the publisher, the language, the Creative Commons licensing details, and the option to generate a citation in various different styles. We could say Harvard and copy that to the clipboard. And we can also export the metadata for this upload in any of these formats and export that. So I believe that concludes the demonstration for Zenodo. I wish now to progress on to the Creative Commons license chooser. So that is this website here. So you can see I've got it bookmarked. This is the page you'll be presented with. And it reads here, follow the steps to select the appropriate license for your work. This site does not store any information. First question, do you know which license you need? No, we don't. Do you want attribution for your work? Yes, we do. Now it's all automatically generated a suggested license, Creative Commons attribution. But there's some further questions to answer. And do we want others to allow others to commercially use our work? No, I'm going to say no. And do we want to allow others to remix, which is probably not the most relevant word to use in research, but do we want them to be able to adapt or build upon the work? Yes, we do. Sharing, do we want them to share under the same terms? Yes, we do. And we click next, and we can see it's generated a Creative Commons attribution non-commercial 4.0 international license. Now we just have to confirm these three clauses. I own or have authority to license the work. I have read and understand the terms of the license, and I understand the CC licensing is not revocable. And we click next. And then you would simply just have to fill in some details. So we've got the title of the work, the creator of the work, a link to the work. We've got, in fact, it's possibly not a good idea to use the sandbox instance example because that already has assigned its own Creative Commons attribution license. But anyway, you can add a link to the work, a link to the creator profile, and you can add a year of creation. And you would finally click done, and that would apply the license to your work. You've got details of your work here, and you can see the license deed by clicking this link here. And you can also get a citation for your work or mark your work using a citation. For a website, whether you need rich text here, and you can change the license abbreviation to a full license name and copy that to clipboard. You can also generate an HTML reference, and you can download the XMP, or you can generate a citation for print work or media. And we see here again, we've got the license abbreviation, which we can change to a full license name. Copy that to clipboard. So that's really the end of the content for today's webinar. I've shared the location of this presentation, and there are some further resources and links on this slide. You can, of course, contact me for any follow-up queries, or if you have any thoughts or contributions regarding open data in scientific research. My email address is stephen.pryce@manchester.ac.uk, so please do get in touch if that's the case.